Mathematics is, in its own way, the poetry of logical ideas. A very good morning to all the participants from DG Vaishnav, PG and Research Department of Mathematics. Prayers don't have to be long and elegant. They need to come only from a sincere and humble heart. Let us begin our session with the Tamil Thai Varthu and prayer song.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராறும் வதனமென திகழ்வரத கண்டமிழில் எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் மிகுந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ओम शांति शांति शांति.
I request Dr. S.U. Malini, Assistant Professor, PG and Research Department of Mathematics, DG Vaishnav College, to welcome our participants.
Happy morning and a warm welcome to one and all. On behalf of PG and Research Department of Mathematics, it gives me immense pleasure to welcome you all to this national webinar on application of epidemiological model to quantify the spreading of fake news in social media. Yes, it is the need of the hour. Social media as such has a lot of advantages related to effective communication, awareness, removal of ignorance, and so on and so forth. But along with that, it also has certain disadvantages when it comes to authentication of information being spread by social media. When this is a scenario, the need for such webinars becomes relevant and vital. Dr. Pooja Kurana, the resource person for the day, is actively involved in research related to this field. I warmly welcome you, madam, for having accepted our invitation and being present here to enlighten our participants. These kind of programs are not possible without the support of college management. I thank the Secretary, Shri Ashok Kumar Mundraji, and our ever-enthusiastic principal, Dr. Santosh Babu, for their continued support and encouragement. I will fail in my duty if I don't thank our head of the department, Professor R. Venkatramanan, without whom such initiatives wouldn't have been possible. Once again, I warmly welcome one and all.
Dear participants, feedback form will be posted at the end of the session. We request our participants to fill the details carefully to receive the e-certificate. It's time to introduce our resource person. I request Dr. P. Usha, Assistant Professor, PG and Research Department of Mathematics, DG Vaishnav College, to introduce our resource person.
A warm and pleasant greetings to all. A good teacher can inspire hope, ignite the imagination, and instill a love of learning. With these warm words, I am glad to introduce the eminent speaker of this day, Dr. Pooja Kurana, Associate Professor, Department of Mathematics, Faculty of Engineering and Technology, Manav Rachna International Institute of Research and Studies, Faridabad. She has completed her post-graduation at Punjabi University, Patiala, Punjab, MPhil at Madurai Kamraj University, and her doctorate in mathematics at Singhania University, Rajasthan. She has 15 years of experience in teaching with 8 years in research. Her field of specialization includes numerical analysis, operation research, algebra, number theory, and discrete mathematics. She has received many meritorious awards in teaching and research. Not only she excels in academics, but also she has received awards for her extraordinary paintings. To her credentials, she has published more than 15 research articles in both national and international reputed journals. At present, she is guiding 3 research scholars of MRIARS. She is a prestigious author of the research book Mathematical Models on Communicable Diseases and also Current Trends and Application in Cognitive Computing as a chapter in research book Taylor and Francis. With the short introduction on behalf of Department of Mathematics, DG Vaishnav College, it gives immense pleasure to welcome our speaker, Dr. Pooja Kurana, to enlighten us today by her talk on application of epidemiological model to quantify the spreading of fake news in social media. With her excellent, extensive knowledge on this topic, I hand over the session to our speaker, Dr. Pooja Kurana. Ma'am, the session is yours.
Thank you so much, ma'am, for wonderful introduction. And I seriously thank from the core of my heart to give such a beautiful chance to speak to all of you and share this platform. And seriously, I am running short of words because it's like dream come true when you speak to all the participants and you share your knowledge with all of them. So once again, thank you so much for giving me this beautiful chance. So shall I share my screen, ma'am? Shall I start?
Yes, ma'am. Yes, ma'am.
My screen is visible, ma'am?
Yes, ma'am. Yes, it is visible, ma'am.
Okay,
Yes, ma'am.
okay. So today, as ma'am told all of you that my topic of research, I mean this topic of today's um, is application of epidemiological model to quantify the spreading of fake news in social media. So first of all, it is mandatory to introduce the concept of mathematical modeling. So what is the basic concept of mathematical modeling? What is the meaning of mathematical modeling? So we'll start with the introduction to mathematical modeling first. So as an introduction to mathematical modeling, we will cover all these contents, like what is mathematical modeling and its importance, and what is its process, the factors of mathematical modeling, and role of modeling in biological sciences, and what is the role of mathematical modeling in social network analytics, and what are the classification of models. So as we all know, the dictionary meaning of model, what is model? Model is to represent something. When we represent something, that is called model. So modeling basically is a process or a way of representing something. So way of representation and process of representing something is called modeling. And when we do modeling of mathematical terms, that is called mathematical modeling. Now what we basically are supposed to represent, the nature or behavior of the system, or what I mean the activities involved in it, what we basically want to represent. And again, what are the ways, the various ways to represent a model. So there are many ways. It may be done by drawing, or by verbal arguments, or a physical structure, or a mathematical formulas. So there are so many ways by which we can represent a model. So basically mathematical modeling is a process of representing a system with the help of mathematical formulas, and the mathematical model is the structure obtained. Okay, so this is the dictionary meaning of mathematical modeling. So why mathematical modeling is important? What is its importance? Why do we need mathematics to represent our system? Is it going to help us out? Okay, so answer is yes, of course. It helps to represent our system, and it plays a vital role in analysis of the system, which other models like physical, chemical, linguistic, etc. cannot. So how but see, when we simulation on the models, when we do simulation of models like experimental on actual system, and what is the best way to understand the physical behavior of the system, and the economic way for measurements, and what are the control on parameters, and the last but not the least, it allows us to predict the future nature which have not been seen so far. So these all can be done using mathematical modeling only. So this is the importance of mathematical modeling, why it is important to represent our system, and to simulate, to find the best way to understand the physical behavior and the economic ways of the measurements, and the controlling of parameters, and to predict the future nature of any model. So mathematical modeling is very, very important, and it plays a vital role in all these aspects. So basically, what is the process of mathematical modeling? But first of all, you need to think of the system, what is the actual system is, and then you need to define the variables and parameters. As you all know, mathematics is all about assumptions. So you need to assume that, okay, what parameters and variables would work on your real life problems which you are thinking to model in the form of mathematics. So then you need to construct equations with the help of those parameters and variables. And when you have the equations, you basically need to satisfy the need of the actual model. Means what you basically want to transform from those equations, which you were having in your dreams, and you want to just have the standby of that model with the help of these variables and parameters and the equations. And of course, yes, then you need to check the reliability and validity of the model. If it works, then you need to solve the equation which you have derived with the help of different variables and parameters. And if it does not work, then you again need to change the parameters, and you need to validate your mathematical model. So process of modeling is like, you need to first create an actual system, and then you need to define variables, parameters, and then you need to construct equations out of those variables and parameters. And now you need to check whether these equations are actually satisfying your actual model or not. Yes, you are computing your model output. If it is valid, then it is working. Otherwise, you need to again go to the definition of that variables and parameters, and you need to change your parameters as per your need. Okay, so what are the factors now? What are the factors of mathematical modeling? So after developing a mathematical model, when you have developed a model, there are some parameters on which it should be judged for applicability. Means that parameters are very important and play essential role in developing a mathematical model. And so few important parameters. See, there is a list of parameters, but I would like to share few parameters which are important. First of all, the scope of the model. I mean, is the model able to define the scope of chosen real world problem? What problem you have chosen is the model is defining the scope of that particular model which you really want to come in, create in the real world. Okay, and the second parameter which is again important is complexity. So is the model too simple or is it too complex in terms of parameters involved? Means what basically, are they sufficient enough to represent the actual nature? So complexity of the model is again an important parameter. And then the computation, how you compute your mathematical model. What is the computational cost of the model? Means, is it reliable or is it not reliable? And the next factor again which is very important is accuracy. This is very important and essential parameter for factors of mathematical modeling, like accuracy. Does the model procedure accurate or close to accurate outputs? Is it giving the authenticated results or not? And yes, the stability. Is the model stable? And if it is not stable, then why we are creating such kind of mathematical models? And the consistency is like very important, and it basically tells the behavior of the mathematical model with the given perturbations. So scope, complexity, computation, and then accuracy, stability, and consistency, these are the factors which play important role in the mathematical modeling. And yes, why we are creating, what is the application of mathematical models? As we all know, all real life problems are just related to mathematics. So mathematical modeling has application in almost every field of engineering and sciences, whether it is to study the crime rate, sociology, or if you just need to construct a building, then you are doing engineering, or to analyze the patterns also, analyze the patterns in planets also, like astrophysics, and everywhere mathematical models help us. And in day-to-day life, we might have questioned ourselves, for okay, how like the current of electrons flow, how the current flows, and this is as per Ohm's and Kirchhoff's law in physics, like how tea leaves start dissolving in boiling water, Fick's law, and why the water come out of the tap in a very nice manner, and this is the answer is given by Navier-Stokes equations. So all these questions have been answered by great scientists. So mathematics has application in almost every field of engineering, and our day-to-day life problems are related to mathematics, and the solutions can be obtained only with the help of mathematics. And all these and many more related queries can be solved by designing a suitable mathematical model. So you need to first you need to first find the which problem you are facing out, and then you need to find the solution with the help of model. And for that, you need to simply first design a model, and then you need to check all the factors of the mathematical modeling. Those I have already covered. And basically, if we simply go in the biosciences, what is the scope of mathematical modeling in biosciences? So you might have amazed by looking at nature's beauty. For example, why each flower and fruit have some different and specific patterns, and why the flock of birds fly in some specific pattern, and how some animals got strips on their body, and many more. Like these examples in biosciences there are so many examples, and the scope of mathematical modeling arise over there also. And we'll be astonished to know, okay, all the natural phenomena are related to mathematics. So I think it's very interesting. So every the small things in the nature is also related to mathematics. And specifically in biosciences, these mathematical models are used to diagnose and treatment of the disease, in the field of biomedical. And if we go in the field of botany, and then how the shape of plant and how they grow and how they take the shape. Okay, and design artificial body parts in bioengineering, and enzyme kinetics and chemical reactions in living bodies, biochemistry, and survival of population with limited resources, and ecology. So all these examples are related to the mathematical modeling in biosciences. So basically, what are the mathematical methods of modeling? What are the mathematical models of modeling. So, any real world system can be modeled by three basic models. The first is forward modeling, and the second is inverse modeling, and the third is mixed modeling. So when we talk about forward modeling, that means we are solving for outputs with assumed inputs. That is forward modeling. So you are going for finding the results with the help of the material you already have. And what is inverse modeling? You are solving for inputs and outputs with known states and parameters. And if it is mixed, when we talk about mixed modeling, that means we are talking about mixture of forward and inverse modeling. And there are different techniques which we use in mathematical modeling, like a classical approach. And when we talk about classical approach, what we include: differential, integral, and difference equations also. And when we talk about stochastic approach, that means statistical models and probabilistic models, stochastic differential equations. These are come under the stochastic approach. And the computer simulation. Computer simulation means it is mostly used where analytical methods are sometimes a cumbersome process. So we use computer simulation to find the solution where these analytic solutions are not giving the good results. And the next comes is operation research, and when you need to optimize and control theory, these two can be used under the operational research. So these are the various mathematical techniques. Other methods are like fuzzy logic and topology, differential geometry, etc. So many techniques in mathematics are there which we use in modeling. So basically, I have already told you about the mathematical, what is modeling, why we use the modeling. And okay, when we talk about the classification of models, I have already, this is the graphical representation of the modeling, which I have already covered in my talk. So these are the different types of models which I just want to throw some light upon. So when we talk about classification of mathematical models, the very first model which is very important is linear. And okay, linear versus non-linear models. When we call a mathematical model is linear model, and when we call it is a non-linear model. So a function or an operator is called linear, as we all know, if it follows the principle of superposition, like f of ax plus by is a times fx plus b times fy. If all the functions and operators involved in the model are linear, then it is called linear model. Otherwise, it would not be called a linear model. It would be a non-linear model. And linear models are relatively simple to analyze as compared to non-linear models. And if we just want to analyze the non-linear models, sometimes like linearization techniques are used to convert it into first linear model, and then we analyze non-linear models. Okay, let us consider a very simple example. Like we have xn plus 1 is equal to rxn. It is a linear equation. But when we just convert it, xn plus 1 is equal to xn into r times x0, 1 minus xn, it would be non-linear model, because r is any constant. Okay, and we need to verify this result by putting the constants of a and b as per your choice. So the second model, the second classification of the second type of mathematical model is static versus dynamic models. And the static model accounts only for steady state. Okay, that is when system is an equilibrium state, and hence it is in the time invariant. And when we talk about dynamic models generally deal with time dependent changes and in the state of system. These are typically represented by difference or differential equations. I'll come to differential equations after some time also. Okay, so the next is discrete versus continuous. So when we talk about discrete models, time model only treats objects at countable time steps. Okay, and continuous time models deal with continuous time. Like for example, dy by dt is equal to y. This is the model. It is a continuous time model because dy by dt is equal to y, and it is depending upon the dependent variable y in terms of t. But when we talk about discrete time model, it is countable time steps. It has limited steps and not in the form of decimals or like that. So xn plus 1 is equal to rxn is very simple example of this discrete mathematical model. The next comes is very important, again, deterministic versus stochastic models. So if every variable state involved in the system can be uniquely determined by the parameters in the model, that is called deterministic. Like length of hypotenuse can be determined from the length of base and perpendicular at the right angle triangle. So this is an example of deterministic model. Okay, and if we talk about the stochastic modeling, if any of the variable state shows random nature rather than unique, then this model is called stochastic. For example, you need to predict the raining for in next month, prediction of raining in the next month. So these type of examples come under stochastic modeling. And yes, of course, there are different models, autonomous versus non-autonomous. And autonomous means in which ordinary differential equations does not depend upon independent variable. When variable is time, and the model is referred as time invariant model. For example, again, dy by dt is equal to y. And a system is non-autonomous, which is, it is also called non or not autonomous, when it is transformed into dynamical system, and vice versa, like with a very weak assumption, like dy by dt is equal to sine of yt. So these are the classifications of mathematical models. And so we have, so far we have discussed what is the use of mathematical models, especially in the field of biosciences, what is the procedure and the characteristics, and what are the methods of modeling, and what are the types. And the scope of this introduction to mathematical modeling is like forward modeling, classical approach, difference and ordinary differential equations, linear and non-linear differential, and discrete and continuous time. Although we have included models from biosciences, but they are very similar, which can help other field students also to learn the methods of modeling. So I have already covered all these classification part, linear versus non-linear. These are the graphs. As we all know, linear graph looks like the first graph, and the non-linear relationship is like represented by the second one. Okay, and these are the simple examples which I have, the pictures also, which I have included with the help of Google. And so these examples shows, okay, what is basically linear model, non-linear. And this ECG report of a normal person, it includes both linear as well as non-linear behavior. And deterministic models, stochastic models. This is again the I have included this picture from the internet. So it is a beautiful picture showing the proper behavior of deterministic and stochastic model. And yes, I've already covered when you have fixed x and you are getting fixed y, and that is deterministic. And when you are not getting fixed y, there is a randomness in the behavior of y, that is called stochastic modeling. So these are some simple examples which I have included, and I have already covered all these models, the classification, and these beautiful pictures I have included from Google only. So this is again the natural pictures. Number of rabbits in a field is discrete, and number of messages which are being sent with the help of social media is also discrete. And donut eaten is also comes under the category of discrete nature. And okay, if these are the examples of continuous mathematical models. And again, so I've covered all these, and qualitative and quantitative. When you talk about quality, that comes under qualitative models. And when you talk about the quantity, and that comes under quantitative models. So these are some examples. Okay, now let us come to different important, again, not important, interesting mathematical models. The first one is population dynamics, because my topic is related to the field of epidemiology. So these are the alphabets. These acts as the alphabets for creating the words in the field of epidemiology. So base is, I think, very important to let you all know. Why I have chosen the SIR model, epidemiological model, to quantify the spreading of fake news over social media. What is acting as a backbone? So epidemiology is basically acting as a backbone, and for this, epidemiology means mathematical modeling. So you need to first know what is the base of mathematical modeling. Like okay, when we talk about the population dynamics, and population dynamics is when with the current world human population, it is more than 7.2 billion, and we might be questioned about the rate of increasing and their survival conditions. So there is a famous book written by J.E. Cohen, and the title of the book was like, how many people can the earth support? is in this he relates the historical and scientific factors for the same. But the question here is that can we study these factors mathematically? So the answer is simply yes. Yes, we can study these factors mathematically. And the stream of bioscience which deals with such questions is known as population dynamics. Okay, when you just need to find the answer, okay, then how many people can the earth support? Yes, we can find the solution, I mean the answers to these type of questions, and with the help of this population dynamics. And modeling the growth of population as a dynamical system driven by biological and environmental processes is called population dynamics. So this again is an important aspect of mathematical modeling. And the next come is like I have mentioned, I've only mentioned the name of these models, and like Fibonacci rabbit model. Okay, let us consider the problem of rabbit generation, which was originally postulated by Fibonacci. Okay, and the problem was like a young pair of rabbits, one of each sex, is placed on an island. A pair of rabbit does not breed until they are 2 months old. When they are 2 months old, each pair will produce another pair in each month. Okay, so this equation represents, okay, if I just put the value of n is equal to 1, if fn is the number of pairs of rabbits present after n months, okay, then n is 1, 2, 3, and so on, as n is a natural number because n is representing the number of months. So f1 is, if I just replace n by 1, what do I get? F1. F1 is the number of pair of rabbits after 1 month, which is 1. Okay, and if I put n is equal to 2, that would give me the number of pair of rabbits after 2 months. Okay, and the answer is again 1. But if I put n is equal to 3 here, so that would be 1 plus 1, which is 2. So this mathematical model, which is fn is equal to fn minus 1 plus fn minus 2, valid only if n is greater than or equal to 3. And this is called a linear difference equation. And this is a form of linear difference equation. So fn is equal to fn minus 1 plus fn minus 2. So this what is this? This is the representation of that rabbit problem with the help of mathematics. So this is a kind of mathematical modeling. This is a mathematical modeling, kind of. It is a mathematical modeling because we have used the concept of mathematics and mathematical symbols to represent a real life problem in the terms of maths. Okay, so as we all know, if we just need to solve the linear difference equation with constant coefficients, and what you basically need to do is, and the number of roots you need to find, and the number of roots depends upon the all of us know, okay, how to solve linear difference equation with constant coefficients and with variable coefficients, and we can find the solutions in a very simple way. Okay, and as we can see, it is a linear homogeneous difference equation, so no need of finding the particular integral for this question. Only the characteristic roots and the characteristic equations you need to find, and then you need to find the roots of the equations, and the roots of the equations are called characteristic roots, and these roots help in getting explicit form of the solution. So if the roots are complex, we know, okay, the solution will lead to in the form of sine and cosine terms, in the form of complex conjugate pairs. Okay, so if I also just want to check the stability of any model, I need to simplify the analysis of this Fibonacci rabbit model with the help of stability, and so many methods are there. Graphical approach is there, and the second model, which is again very simple and important, is linear cell division model. And linear cell division model is, let us assume that a cell division takes place concurrently, and at each time cell is producing alpha number of daughter cells. Okay, so the number of cells, the density of cells, if you just want to find at the beginning of the cell, if I represent by C0, and after n generations, the number of cells shall be Cn. So this is again the mathematical modeling of linear cell division, okay, where n is a generation number. And this model is of the form of simple linear difference equation, and this model has another name also. This model is called Malthus model, and this is named after the famous English economist Thomas Robert Malthus. So this is again very simple example of mathematical modeling, and you can include the parameters as per your choice. And if you just need to include the birth rate and death rate also, you can change the model as per your convenience. So that would be Cn minus 1 is equal to b minus d Cn minus 1, if you are including the birth rate as well as the death rate also. So, and you need to check the stability. Stability of the same can be analyzed from the previous analysis, like from the Fibonacci rabbit model, and that depends upon alpha. If alpha is greater than 1, it is stable, and if it is not equal to 1, then the behavior of the model is not stable, unstable. And if you just deal with the linear non-homogeneous difference equations, then you need to find the complete solution by finding the complementary function and the particular function, particular integral. So the next again very important is the important model is linear prey predator model. And let us consider a forest which contains only tigers as predators and deer as prey. Okay, the tigers kill the prey for their food. So if Tn is the population of tigers at the end of year n, and Dn is the population of deer at the end of year n. So in order to formulate model, following some assumptions we need to consider, like deers are the only prey for tigers and tigers are the only predators for deer, and tigers will die out in the absence of deer, but deer population will grow in the absence of tigers. And in the presence of deer population, the rate of tiger population growth increases, and in the presence of tiger population, the vice versa. The growth rate of deer population declines. And this is the model, and we can find the solution with the help of matrix approach also. In matrix method, if I just consider the model of this linear prey predator model, like delta Tn is which I have mentioned in my PPT. So in matrix form, it would be Tn plus 1, Dn plus 1 is equal to 1 minus a. Basically, you need to find the mathematical matrix approach, mathematical matrix approach. Okay, and you need to find the characteristic equation by finding the determinant of a minus lambda is equal to 0. And why we are finding the determinant of a minus lambda? Basically, we are trying to find the equilibrium point with the help of eigenvalues. Eigenvalues play an important role in checking the stability of the linear system. Okay, in the matrix approach. So if all the eigenvalues are greater than 1, then we simply say, okay, the system is unstable. It is not stable. It shows the unstable behavior. And if all the eigenvalues are less than 1, we said, okay, our system is stable. That this property, this stability condition, I'll be using in my spreading of fake news through WhatsApp. I have checked the stability of spreading of fake news with the help of this stability only. And if lambda is greater than 1, non-stable. If it is less than 1, then the value is stable. But if it is less than equal to 1, then it is asymptotically stable at the equilibrium point. Okay, so these are some mathematical models. And now if I just want to check the graphical solution of first order linear differential equations. So far we have discussed only about the analytical solutions, and with the help of analytic solutions, it is not always possible to obtain solution to certain limitations. And here we need some other general method to deal with any kind of difference equation. So like in this case, graphical method may help us in analyzing the situation, although it will not give us the equation form of the model, but yet it will help us to understand the behavior of the system. And the way of solving difference equations graphically is called cobwebbing method. And this method, please make it a point, it is applicable only for first order equations, and it is called cobwebbing method. So if I just take an example of general example, like xn plus 1 is equal to f of xn, which I have mentioned in my PPT. And these are some steps of drawing a graph using cobweb as follows. You need to first draw the graph of y is equal to f of x, and then you need to make a line y is equal to x, and these points you need to cover. So this is the graph which I just want to share, the stable behavior. So if I just fix the value of fx is equal to 0.5x, and you can simply see the behavior of the graph is stable. Why it is stable? Because all the vertical and horizontal lines are decreasing. So it shows the stable behavior of the problem, while the next one shows the unstable behavior of the equation. Like if I just change my equation f of x to 1.8 into x, and the graph looks like this only. And here we can observe that all the vertical and horizontal motions are increasing, and the system is showing the unstable behavior. Okay, so there are other methods also to I mean, like how to check the physical. I mean, what is the basically what is the basic use of eigenvalues? What is physical significance of eigenvalues, and why we use numerical methods? Why the concept of numerical methods are there? Physical significance of eigenvalues, as we all know. See, by the time we might have realized the importance of eigenvalues in finding and stability in finding the stability of the solution, and hence analyzing the behavior for the same. So, do these eigenvalues describe something? Of course, yes. Or are they only numbers? Eigenvalues, and when we talk about eigenvalues, that means eigenvectors also exist over there, are very well related with the transformation of the system. The need of transformation of the system is to make it easier to study and analyze. When you transform any matrix, you need two things. The first thing is, by what amount are you going to transform your system, and the second is, in which direction you are transforming it. So what is the physical significance of eigenvalues? So here is the need of eigenvalues. And if I just take, okay, let us take an example of 2 by 2 matrix. 2 by 2 matrix is a square matrix, the short matrix. And how many eigenvalues would it have? 2, lambda 1 and lambda 2, say. And let us suppose that, okay, v1 and v2 are two eigenvectors corresponding to eigenvalues lambda 1 and lambda 2. So lambda 1 gives the amount by which one is transforming his or her matrix in the direction of v1. Similarly, lambda 2 and v2 are representing, lambda 2 gives you the amount by which you are transforming your matrix in the direction of v2. If the value of lambda, I mean, if the value of eigenvalue, I mean, if the range of eigenvalue we set as 0 to 1, that means system is, getting contracted in the direction of v. But if we just say, okay, the eigenvalue is greater than 1, that means the system is expanded in the direction of v. And if it is like -1 to 0, if it belongs to the range -1 to 0, that means it is contracted in the opposite direction of v. And lambda is less than -1 means it is expanded in the opposite direction of v. And if lambda is 0, then what? Lambda is equal to 0 means no transformation in the direction of v. So this eigenvalues, show very importance in the field of stability of mathematical models. So this is important to study. And okay, why then the question is there, why we need the numerical methods? Yes, we have seen the physical and mathematical importance of eigenvalues and eigenvectors. We have also seen how tedious job is to calculate eigenvalues and eigenvectors of those matrix of which has high dimension. Also, when degree of characteristic equation is large, like more than or equal to 3, it is not easy to find the eigenvalues. Okay, there are so many tests to check whether how to find the eigenvalues in a unit disk or not. And Jury's test is also there. Okay, but to know the exact solution, we need eigenvalues. Yes, but when finding the solution of a system or an equation becomes difficult task with analytical methods, then we go by the numerical methods. Numerical methods are a very easy and computer-based approach, which we try to converge near the exact solution. Which try to converge near the exact solution as far as possible. And there are so many methods to find the eigenvalues with the help of power method, with LR method, QR method, and one more method is there, householder method, etc. These methods help us to find the eigenvalues with the help of numerical methods. And each algorithm, as we know, has some limitation and some advantage. So power method and LR method we already study in our PG courses, and which is used to find an arbitrary matrix, which is used to find the eigenvalues for an arbitrary matrix. And power method is used to find the numerically largest eigenvalue. So this is basically, these methods are computer-oriented methods, and to find the numerically largest dominant eigenvalue of a given matrix and the associated eigenvector also. And these are iterative methods, as we all know. These are indirect methods. So we need some initial assumptions to start the process also. So this is the limitation. We need to fix some initial assumptions to start our method for finding the eigenvalues, because these all are iterative methods. And after each iteration, we also we will compare the solution obtained with the previous iteration solution for the convergence. And if after some iterations, okay, we see the two are, I mean, likely to be same, and then we say, okay, the solution is now converging. So, I mean, this is related to the accuracy of the method of a particular matrix. And basically, these methods are computer-based approaches for finding the eigenvalues, and which we use in the mathematical modeling. So this is the overview which I have already discussed with all of you. And when we talk about age structured model, we need to add the parameter of age in that particular model. And okay, now what is basically the next is, what is the meaning of, I mean, when we talk about continuous time models, and the concept of differential equations comes over there. And in my previous talk, I mean, just before this continuous time modeling, we have studied and analyzed the discrete time models only. So when we talk about continuous time modeling, and if we observe the natural phenomena, all of them are, depending on the time continuously. Okay, then why did we use discrete time models? Okay, but there is a very close link between discrete and continuous time models. If numerical methods like finite difference and finite element are applied on continuous time models, then we get only discrete time models. So sometimes we simply convert our continuous time models with the help of finite difference and finite element method of numerical methods to just get the discrete time models. And we all are aware of using numerical methods in the in those cases where finding the analytic solution is a cumbersome or sometimes impossible task. But this is not only the case where discrete time models are being formulated. If the data are given at discrete points, like for example, population data given for every 10 years interval, then also discrete time modeling is done. So it is not mandatory that, okay, we always go for continuous modeling. These two are interrelated to one another. So two important reasons to use discrete time models were like when data points are at finite distances and to solve the difference equations. And when you, I mean, are discrete time models able to show the actual behavior? No, they have some limitations. The major disadvantage of using the difference equations, is the dilemma of choosing the type or order of difference equation. So it is a matter of accuracy, basically. When any differential equation is characterized to form difference equation, then we must care about the accuracy first. If there is no accuracy, then why we are doing all this, I mean, process? And the accuracy of solution generally increases with the increase in the order of difference equation. And we must take care of the cost also, okay, because computational cost is play an important role. So to overcome the limitation of discrete models, we need an formulation of the continuous modeling. So in a proper equation for representing all the datum in continuous mode, we require continuous time models. So both of these two are important. With the classical approach, deterministic continuous time dynamic systems are formulated only by using the differential equations or partial differential equations. Basically, as we all know, what is differential equation? When we when it involves derivatives, differential operators in it. And a differential equation is termed as ordinary differential equation if there is only one independent variable and rest all are dependent. And when there are more than one independent variable involved in the differential equation, okay, we simply call that equation as the system as partial differential equations. So, and we all know how to solve differential equations using different methods are there for solving ODEs, ordinary differential equations and partial differential equations. I know all of us know how to find the order and the degree, because that also depend upon that also is the major requirement for checking whether the ordinary differential equation is linear or non-linear sometimes. So it is also important. Solution, you need to find the solution. Means you need to find the relationship between all the dependent and independent variables involved in your differential equation. And general solution also, and in which there are arbitrary constants. So basically, we simply find the solutions. Okay, I have simply taken one example to solve the differential equation dy by dx is equal to x. As you can see, you can simply find the general solution by simply integrating by separating the variables and simply by integrating. It's quite simple, and see the beautiful graph of this differential equation dy by dx is equal to x. So this is the behavior of this is the beauty of the mathematics. With the help of the equations, you can plot the graph and you can check the behavior of your real life problem which you have modeled in the form of mathematics. And when we talk about what is the meaning of geometrical meaning of differential equations? So again, this graph shows the geometrical meaning of differential equations. We are finding the slope of the curve gxy is equal to 0 at the points, at different points, as we can see in the graph. And it is when we just simply replace g at initial condition, like when we simply choose a point x0 y0 and we are getting g x0 y0 is equal to 0, this is called the particular solution of the differential equation. As we all can see the number of slopes in this graph, and it is showing the geometrical meaning of the differential equation. And these are the methods, as we all know, okay, how we solve these kind of differential equations. I mean, first degree differential equations can be solved using method of separation of variable, and homogeneous differential equation method is there, and linear equations. So these are some important methods. I mean, these are the mathematical models, and their solutions have already been discussed by various mathematicians, and so many books are there with the help of which you can find the solutions of, differential equations. And every time we are dealing with differential equations in our day-to-day life. When we talk about linear equations, that means Leibniz and Bernoulli's, and solutions, as we all know how to find the solutions of those two. And okay, now let us start with this epidemiology. What is the importance of epidemiology? What is epidemiology, and why we need the epidemiology? See, basically, when we talk about epidemiology, and that this word is there in my talk also, in the title of my talk. Epidemiology is basically a Greek word, and it derived from epi, and then demos, and then logos. Epi means upon, on, or upon, and demos means people, and logos means study. So basically, the meaning of the word as a study of distribution and determinants of health-related states or events in a specified population. And the application of this study is to control the health problems. Basically, when we talk about epidemics, and see, we all are facing this corona pandemic, and that is also again a type of epidemic disease. And so basically, when we just want to control the health problems, this term play an important role over there. The main purpose and the main aim, for the epidemiology, is to determine the number of cases of disease in a particular area. Epidemic means the disease is restricted to particular area, and during any particular time period, or the frequency of an exposure among persons with the disease. In short, if I just want to explain this epidemiology in a single line, basically it is the study of disease to determine how often it happens, and the reasons behind that is termed as epidemiology. And frequency and health events pattern in the population are the main determinants of this term epidemiology. Frequency means the relation of the number of cases of a particular disease in a population of that of the size of the population, whereas pattern refers to happening of series of health related events by time, person, and place. Epidemiology is basically considered as an essential part for the basic illustration of a particular disease. Information from epidemiological studies is used to describe the development of strategies in order to prevent illness and to control. Okay, and for the patient management who has already developed symptoms for spreading of any kind of disease. And of course, risk factors are there. Risk factors we identify also in just to control this epidemiologic diseases. Also, risk factors we need to control also, and some precautionary measures we need to take. And okay, the treatments also play important role in in controlling the disease of this epidemic category. And basically, it is like what to say, means every population is susceptible to prone to have any kind of disease, and when one person gets infected by any of the disease, that means he or she comes under the class of infected, and then again the process starts, and this epidemic model comes over there and play an important role. So basically, when we talk about epidemic model, the very first model that comes into account is SIR model. And SIR model is basically, before SIR model, SI model is there. And as you can see, in SIR model, S is representing the susceptibles, and I is representing the infected persons. So actually, why we are studying this epidemiologically? Because epidemic controls, it attempts to capture the dynamics in the spreading of a disease. That disease can be idea, that disease can be computer virus, that disease can be product adoption, any. I mean, if you just want to find the answer to, the questions like, how do contagions, this infection spread in the population, and will a disease become an epidemic, or will a disease become a pandemic? And okay, who are the best people to vaccinate just to control the spread of the disease? And will a YouTube video go viral? It means disease means any idea, computer virus, any product adoption, any fashion technology, anything which persons can, they are prone to adopt those kind of things. And then what individuals should we market to, for maximizing product penetration? So when we talk about classic epidemic models, the first comes in our mind is simple, this SI model. And when we talk about SI model, susceptible infected model. And here ST, both S and T, are time dependent. So this ST represents the number of individuals who are susceptible to sickness at any time. And what is I representing? I represents the number of individuals who are infected at time t. So, and the total population size we consider as n. So you can see the differential equation model for this. This is very simple, and just if we are just considering, okay, that there is a rate called beta, which I have mentioned in the differential equation, ordinary differential equation. So S upon n is basically the probability of meeting a susceptible person, because there is a probability of meeting a susceptible person at random, per unit time. And beta is what? Beta is the infection rate. That is probability of contagion after conduct per time. So this is the model, and ds upon dt is equal to minus beta s x upon n. Why the minus sign is there? Because number of susceptible persons are getting decreased with respect to time, because they are entering into the infected class. So this is the logistic growth curve. As you can see, this is the behavior of SI model, susceptible infected model. And simply you can solve the differential equation model to find the solution using graphical approach. Okay, and the next come is again SIR model. Here I have included the recovered compartment over there. This is compartmental model. There are basically three models. S is for susceptible, I is for infectives, and R is for recovered. Okay, so this is SIR model, the very first model given by Carmack and Mandrick. And this was the first model where they have introduced the compartment R. Okay, and if I just consider, okay, beta is the infection rate, that is the probability of contagion after contact per unit time, and gamma is a recovery rate, because the persons who are getting infected, they are getting recovered after some time also. So that's why they have included one compartment model over there. And it would be a system of ordinary differential equations, as you can see. So ds upon dt would be, I have mentioned in my PPT, it's minus beta si, okay, sx. Okay, I have considered this x as infectives, and at the same time, some persons are getting recovered. So positive sign in the second equation shows that, okay, the persons who are getting infected, they are getting recovered also. At the same time, the persons are getting decreased from the category of I, and they are increasing the number of people in the recovered class. Okay, so this is the system of ordinary differential equation, and the graph of SIR model is very basic model. Here, this S line is showing the susceptible behavior, I is showing the infected behavior, the I colored line, and R is the recovered number of the persons who are getting recovered. Okay, let's come to SIR model for fake news spreading over through WhatsApp. How they are, how people are spreading fake news over social media. Social media, as we all know, play a vital role nowadays, and everybody is in contact of so many persons in our daily life. So when we talk about, see, this is one application which I have used in my paper, that okay, how this SIR model works on spreading of fake news over social media. But first of all, let me tell you one thing. There are so many types of SIR model. Also, you can add you can consider SIS model. You can consider SITR model. I mean, T is the treatment, which treatment compartment you can simply add on. And so many methods are there. SI1, because after getting one infection, it is not mandatory that you would fully recovered, you would get fully recovered. You may have another infection as well. So many of papers have shown this, the different type of models also, dependent upon this SIR model, like SI1T I2RS model. Means you are getting recovered from the first infection, but again you are getting infected with another infection. Okay, like diabetic people, they are more prone to have more diseases. And this is these are the different types, different types of mathematical models. So basically, what is the importance of, now why we are using SIR model on social networks? Because social networking is what? Social networking is a modern advancement of science. And everyone has a chain of friends, colleagues, and partners. I mean, chain of entities they are having, and they are all connected by antisocial connections. So social networking is a nice form of fun. Yes, of course, it is a place for finding and meeting people, and staying in touch with your old friends and colleagues. It is an effective promotional tool sometimes, because of businessmen and entrepreneurs. What they do, they basically just want to uh, uh, they they have the chance to promote their product. So it is important to have an account on the social media also, but it has, at the same time, it has negative effects also. So it is basically a committed internet site which permits user, after talk together with everyone by posting information and comments and messages and images sometimes. Means you can share your data with anyone with a very short span of time. So it is internet based social media, that and its applications to rearrange connection with the friends, classmates, and clients. And it can occur for social purposes sometimes, and business purposes, for such as like Facebook, Twitter, LinkedIn, Bebo, Classmates, Instagram, MySpace. So many social networking sites are there. And this is the easiest way to understand social networking, and is to think of like we were having when we were like in our school. Okay, we would have thought about, okay, this kind of technology, now we are using this kind of technology, and it is a meeting place for expand their range and remain in contact with their associations. And we are also in contact with most of the persons which I was having, which we all were having, okay, in our school time. So person to person communication is not the static thing. Now systems are developing and changing constantly, and with the new flying up rates, we are adopting new technologies. And many systems are there, okay, with particular interests and needs, and everybody wish to join these sites. And many individuals, they have their loved ones, and they are utilizing the application, and they need to remain in contact. but what we have been utilizing the social network site for positive aspect? No, it has, I mean, every coin has two sides, both pros and cons are there. So we will certainly interact with our friends, and knew long before, but these are awesome spots. But this shows the negative behavior sometimes also. I mean, let us consider the concept of fake news over WhatsApp. So WhatsApp is now an instant messaging social media platform, which allows author to send and receive information. I don't know whether the information shared by, we don't know whether the information shared by all of them is authenticated or not. But sometimes we believe, okay, yes, this is the correct news. We should follow this, and we should also, forward it to our group, forward it to our groups also. So without thinking, we simply spread these kind of messages which are fake, which are not authenticated with all of our groups, basically with the framework of our friends. Okay, so because it is an instant messaging social media platform, and 600 million people are using this this app, this social media app, WhatsApp. Okay, and the study which introduces a framework to compare the dynamics of WhatsApp based on the topical age group. Also age group play a very important role in this. So basically when we talk about social network and online social network, uh, fake news in India is a growing problem nowadays, and the practice of use of social media platforms like WhatsApp and to popularize any fictitious information which is leading in a dangerous direction. So basically we should always think we all comes under the susceptible class. Without thinking, we are spreading these kind of fake news to everyone, and once we get infected, we are trying to make other persons infected also. So this SIR model is, I have used this SIR model, the application of this SIR model, this epidemiological model, in the for the fake of for the spreading of fake news, not in India, worldwide. Okay, yes, there are advantages and disadvantages also, but what is the mathematics of SIR model in this case when we are talking about diffusion, diffusion of any news which is not real, which is fake, and how mathematics is helping us out. So what is the mathematics of SIR model in this case? See, SIR model is used in epidemiology, I agree, to compute the amount of susceptible, infected, recovered people in a population N. And but the this model is, this model has some fixed assumptions also, like the population should be fixed, and the only way a person can leave the susceptible group is to become the infected, sorry, and the only way a person can leave the infected group is to recover from the disease. And here disease means those who are spreading the fake news over social media. One person, if once a person has recovered, the person received the immunity. Okay, and in this model, basically S is number of susceptible individuals at any time t, I is the number of infected individual at any time t, and R is the recovered number of recovered individual at any time t. So this is okay, this is the representation of SIR model. Alpha is the infected rate, and beta is the recovery rate. So ds upon dt is minus alpha si. As you can see, di upon dt is equal to alpha si. But what I am representing, SIR over here, my S is number of susceptible, that is fine, but they are actually representing the number of feasible authors, those are relevant for spreading of fake news. These are those persons who are prone to spread the fake news over social media with the help of WhatsApp. Okay, with the help of Facebook also. Why I'm using this WhatsApp only because I have introduced the only concept in this PPT. I is the number of wide variety of persons, authors, which particularly of the age group 19 to 24, the youngsters who are highly active for posting the fake information. And R is what? R is representing the range of authors in the age group of 40 to 60. Okay, they think, okay, what we have got to do with these fake news, and they are inactive basically to spread the fake news. So this idea I introduced in my paper. Okay, if I replace S by the number of authors who are relevant to spread of fake news basically, and I is the the youngsters of age 19 to 24, they are highly active for posting on social medias, and they remain highly active during night also. And R is the number of persons who comes under the category in the age group of 40 to 60, and they are basically inactive to spread the fake news information. Alpha is the transfer rate, and beta is the recovery rate, and K is the possibilities of contagion from the individual. So this terminology I have used in my in this paper. So I have already told you about the terminology used. So how we check basically the stability analysis of SIR model? I already told you we simply find the matrix method of ordinary differential equations, as I covered in my previous slides. And how we find the eigenvalues, as we all know, for finding the eigenvalues, we simply need to subtract lambda from all the diagonal entries and we need to take the determinant. And after finding all the eigenvalues, what we see? So we need some data, and this data I have extracted from the internet only. So S0 is 134 million. So this paper was published in 2017. So that time the data was like 134 million people were there who are susceptible to spread the fake news over social media. And these are the infected persons. 58.9 million people were there who are in the age group of 19 to 24, and they are spreading the fake news over social media. And RT, so these are the persons who come under the category of age 40 to 60 years, and they are inactive spreading the fake news over social media. Alpha, beta, gamma, and K, and this mu, I have those parameters. Some parameters I have estimated, and I have used the numerical simulation of the method of this SIR model, and I have computed the eigenvalues. And as you can see, the eigenvalues are, two eigenvalues are negative and one eigenvalue is positive. And this is the graphical representation of this spread of fake news in India. And as you can see, S is the number of susceptible authors, and they are getting decreased because they are increasing the number of infected persons, and R represents the number of recovered persons with respect to time. And this is the graph. As you can see, this is the behavior of SIR model. So I have used this new concept with the help of SIR model. So this is the graphical representation, and basically this is mathematics is very beautiful to represent all the ideas which we have in mind. And first we formulate the model, and then we check the validity, and we find the solution with the help of graphs. And this was like my another paper which I published, the growth analysis of, again, social mobile and mobile social users through internet is very important to spread the fake news over social media. And the second important thing is smart mobiles. So they are the backbone of spreading of fake news over social media. The first thing is internet, and the second is smart mobiles. And this thing I have already covered, and this is the structure. And again, the stability I have checked for the second paper, and this is the behavior of the persons who are spreading fake news, without even thinking whether the news is authenticated or not. So I have used MATLAB also, and you can plot the graphs in Excel also. That is up to you which tool you want to use for showing your results. And basically, SIR model you can apply on so many fields. You can apply in when there is outbreak of anything, you can simply use this SIR model. This is very important and very easy to apply. Where else you can apply so I have represented one idea, fake news spreading on WhatsApp. The second thing is viral marketing. Product information can be popularizing through this social networking site. Okay, and it gives a positive impact on the customer, and we see a lot of people are purchasing things through online shopping sites. What is this? They are getting infected. Infected. Those were are already there in the susceptible class, but with the help of technology, they are getting infected, and they are sometimes getting recovered. So viral marketing of product information is also comes under this SIR category. And audience applause. The very common example is audience applause. When we see when a group of persons sitting somewhere, and one person starts to clap, and immediately the person sitting in the crowd starts clapping. So what is this? That again comes under the class of SIR model. This is the application of, again, audience applause is the application of SIR model. And this spread of computer virus. So some ideas I'm sharing with all of you where you can apply this SIR model, because basically my area is also this epidemiological modeling, but okay, I have used this model in a different manner. And you can also use like for audience applause and for product information and for spread of computer virus. Nowadays, with the increasing rate of information technology, IT, ICT also development, the security of networks is major issue in our daily routine. So you can check the stability of spread of computer viruses again by using the mathematical model, because virus attacks the computer system and damages the software. So we need to secure our computers also from the viruses, and again this model helps us to secure our models, okay, which is the major issue in our daily routine. Okay, and what else? Academic spreading means when a person when one student thinks, okay, I would go for non-medical, I would opt non-medical. Okay, his or her friend also thinks, okay, I would also go for choosing this non-medical stream. So this academic spreading is also one of the example of SIR model. You can again apply SIR model with a different terminology on academic spreading. Here the susceptibles are, you can take the research scholars. Okay, susceptibles are research scholars, and infected are also research scholars, and the carriers are, who are the carriers? Sometimes we need to show the carriers also. Carriers are journals and conferences. So there is immigration into research scholars from the educational stream, whose strength is assumed to be proportional to the strength of the research scholars class. So increase in research journals and conferences also depend upon the number of research scientists. Yes, of course there are pros and cons also. There are pros and cons for each and everything. The basic thought behind building up the computational model is to make things simple and to clarify the application of science and humanism related to the hypothesis. And okay, if I just simply talk about the conclusion of my talk and the future scope, and in this basically in my talk I have focused on mathematical and statistical aspects of the models, yet the most important part is creating models and interpreting results so as to respond to real life problems or situations. Okay, and epidemiology is considered as a fundamental pillar for answering many health related issues, and these kind of social media issues which we are facing in our daily life. And I have already told you some I have given you some basic ideas and concepts where you can apply the SIR model. I've already covered all these. I've not take much of time because time is also running. And so you can use SIR model in many ways: analysis of social media user growth, internet user growth, mobile user growth, and mobile media, social media user growth for the prediction also. Prediction is based on the factors which are estimated on the online data resources. You can take the online data and you can simply estimate your results. So SIR model basically, in short, it can be applied for any prediction of quantity of people that may have the same level of interest on any unique topic, and the behavior with the help of epidemiology, SIR model can be studied and observed. Okay, these networks are not being used in a positive way. Yes, they are being used in a positive way, but with the negative effects also. And I have shown you one research paper of mine, and I'll advise readers not to believe all the news on WhatsApp, and because some of the news may be fake. And thank you so much. I'm done with my talk. Over to the organizers, and I'm open to question answer round now.
Thank you, ma'am. Thank you so much. I think like all our participants enjoyed the speech. Like there's no questions as of now.
Okay. Thank you
Really,
so
there's
much,
no
ma'am.
questions as of now. I think no, ma'am. There's no questions. Would you
Okay,
like
thank
to?
you so much, ma'am.
Excellent.
Yeah,
I
only
mean,
I would only like to thank the organizers and Venkat sir for giving me such a beautiful opportunity to share my knowledge with all of you. Of course, I would definitely look forward for more topics in the future as well. Thank you so much. It was
very, very nice topic,
period.
ma'am. Thank you, ma'am. Thank you so much.
Thank you so
There's a
much,
few
ma'am.
informations for the participants, ma'am. Okay, thank you, ma'am. Dear participants, feedback form will be posted at the end of the session. We request our participants to fill the details carefully to receive e-certificate. Our next webinar is on 21st November.
CMS.
Yes, ma'am.
Subhalakshmi, ma'am.
Yes, ma'am.
There is one question.
Oh, okay. Yeah. Ma'am, I'm sorry. There's one question.
Yes, ma'am.
SIR model benefit. Does SIR model benefit?
Of course, SIR model benefits us. It can help us, spreading the fake news, because I have, mentioned all the pros and cons of, fake news spreading on WhatsApp through SIR model only. Yes, it is benefiting us. We should be very careful, just to get infected from the susceptible class without, going without thinking whether this news is authenticated or not. So how we are using SIR model to, WhatsApp, for, for stopping the fake news over WhatsApp, because we have checked the stability of the SIR model, stability of the fake news spreading through SIR only. So yes, it is helping us to stop the fake news spreading without, relying on the news, and with the help of SI only.
Any other questions? Any other questions? No, I think there's no more questions now.
Thank you
Thank you.
so
Thank
much,
you.
ma'am.
Thank you. Very informative session. No, thank you. There's no more questions now. Thank you. Dear participants, feedback form will be posted at the end of the session. We request our participants to fill the details carefully to receive the e-certificate. Our next webinar is on 21st November 2020 about Introduction to Mathematica presented by Dr. Johendra Kumar, Associate Professor, Department of Mathematics, DIT, University, Dehradun, Uttarakhand. Right? It's time to thank our participants and the speaker. I request Dr. B. Abhirami ma'am, Assistant Professor, PG and Research Department of Mathematics, to give a formal vote of thanks.
Good afternoon, everyone. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, I am honored to have the opportunity to give vote of thanks on this special day. I extend my gratitude to our Secretary, Shri Ashok Kumar Mundraji, and our Principal, Dr. S. Santosh Babu, for their valuable support. Our sincere thanks to the resource person, Dr. Pooja Kurana, Associate Professor, Department of Mathematics, Faculty of Engineering and Technology, Manav Rachna International Institute of Research and Studies, Faridabad, for gracing today's national webinar, Application of Epidemiological Model to Quantify the Spreading of Fake News in South Media. Thank you, ma'am. We are greatly enlightened with knowledge and presence. Our special thanks to our HOD, Professor R. Venkatramanan, for his effort to conduct a series of webinars. I take this opportunity to thank our dedicated staff members and students for their kind cooperation. Our sincere thanks to all the participants from various institutions for their active participation in this national webinar. Once again, I thank one and all present here. Thank you.